Back at AP Review. This is free response 3 from 2011 Form B for both AB and BC. So 2011 Form B, AB, BC for response 3. The functions f and g are given by f of x equals the square root of x and g of x equals 6 minus x. Let R be the region bound by the x-axis and the graphs of f and g as shown much better on the real AP thing, but here's my terrible version of the graph. Part A, find the area of R. So the trick here is that you have to break it into two pieces. You need to find the area under the f curve from 0 to 4, and then you need to find the area under the g curve from 4 to 6. Now, you can find the area under the g curve pretty simply by just using the area of a triangle, or you can integrate it. I don't really care. I would argue that the g curve is pretty easy. To go from 4 to 6 has a base of 2. This is also a height of 2. So I can find the area of the triangular region pretty easily. So when I go to do part A, right, my part A, my area is going to be the integral from 0 to 4, right, of the f curve with respect to x, because it's technically the f curve minus the bottom curve, but the bottom curve 0, right, plus the area of this triangle, which is going to be 1/2 base times height, right? You could also find the triangle by integrating, but it seems like a silly thing to do. So this is actually an x to the 1/2, right? So when I up the power by 1 and divide by the new power, it becomes a 3/2, and then I times by 2/3, because that's the same as dividing by 3/2, and I'm going to evaluate that from 0 to 4, and that's going to be plus a 2, right? So I'm going to get 2/3 times a 4 to the 3/2 minus a 0, all plus a 2. So you do need to know how to evaluate a 4 to the 3/2, like it or not. So 4 to the 3/2, right? The easiest way to do 4 to the 3/2, if we just come over here for a sec, you can either do the square root of 4 cubed, which is the easier option, because that would be 2 cubed, which is an 8, or you could do 4 cubed and then square root it, which is a square root of 64, which is also an 8. Now here, it doesn't really matter which order you do the two operations in, because we know the square root of 64. It's not awful. We can also cube 4 and get a 64. But if this had been like a 9 cubed and also a square root, you would want to do the square root first, because that's much easier, and then cube the result. So anyway, that ends up being an 8. So we get 16/3 plus a 2, which is a 16/3 plus 6/3. So our answer is 22/3. That's your part A. Part B. The region R is the base of a solid. For each y from 0 to 2, the cross sections of the solid perpendicular to the y-axis, and that's really important. Like if I had this written down like on a piece of paper, I would write all over that phrase. I would circle it and highlight it. So what they're saying is cross sections perpendicular to the y-axis, right? So going this way are rectangles whose base in R whose base is in R and whose height is 2y, right? So for each y value, so it's a rectangle coming off, and there's a rectangle here, and there's a rectangle here. Okay, so write but do not evaluate an integral giving the expression for that volume. Okay, so the trick is that the first thing I need to recognize is that this base length, because it's a horizontal line, is this line minus this line, like this line minus this curve, but they're in terms of x, and they shouldn't be. They should be in terms of y, because I'm going to be integrating with respect to y, right? I'm integrating this way. So the first thing I need to do is solve both of these curves for x. So the f curve, right? So f is the curve y equals root x. If I solve for x, I'm going to get y squared equals x. Great, okay. The g curve is y equals 6 minus x. If I add the x over and subtract the y, I'm going to get that x is 6 minus y, right? So the length, this base, right? The length of this base is right minus left. Just like when we do a vertical length, it's top minus bottom. So this base is right, which is going to be this g curve, so 6 minus y, minus left, which is the y squared. I know the height of the rectangle is 2y, right, whatever y value I pick. So that means that the area of this rectangle, which is base times height, is going to be a 2y times the quantity 6 minus y squared. And you can clean that up if you want, or you can leave it, nobody cares. So the volume is going to be adding up all of those rectangles. So it's going to be the integral from 0 to 2 of 2y times the quantity 6 minus y squared with respect to y. That's the volume they want. The reason you have to have it in terms of y is because they went out of their way to say that you're going from 0 to 2 on the y-axis, and also because they said that the cross-sections are perpendicular to the y-axis. That's what makes that problem so tricky. It actually wouldn't be hard to distribute this to y and integrate and solve, but that wasn't what they're testing. They're testing if you could switch the situation to abide by what they asked. Cool. Part C. There's a point P on the graph of f at which the line tangent to the graph of f is perpendicular to the graph of g. Find the coordinate of P. Okay, so that's a lot, but it's not a super duper horribly difficult problem. Okay, so let's think about what we know, right? So in part C, they're saying that there is some f of x tangent line that is perpendicular to the g of x line. Right? Well, g of x is a negative x plus 6, meaning g of x has a slope of negative 1. What it means to be perpendicular is that you have an opposite reciprocal slope, right? Opposite reciprocal slope. So the way I like to tell my students to remember it is that perpendicular means flip slope, change sign. Right? So if you're perpendicular, right, your slope should be the opposite reciprocal of a negative 1. Well, in this case, because of 1, the reciprocal thing doesn't do much, but it does become a positive 1, right? So what we're looking for is a tangent slope that is a positive 1. Well, I know that the slope of a tangent line is f prime, so we're looking for f prime of x to equal a positive 1. Well, I can find f prime, right? F was the square root of x, so f prime, right? So since just as a little note, right, do a little work over here. F was x to the 1/2, so if you derive that, you're going to get f prime of x is 1/2 x to the negative 1/2, although the way we more commonly see it is 1 over 2 root x. So 1 over 2 root x has to be a 1. 1 equals 2 root x. 1/2 equals root x. And I'm going to take a square root, right? So I'm going to get plus or minus the square root of 1/2 equals x. Well, the trick is that I'm in quadrant 1, so I don't need the minus. I can't have a negative x coordinate. So my x is going to be the square root of 1/2, or if you want, you can do a bunch of things to clean it up, right? So it's going to be the square root of 1/2. I did a thing that was stupid. How many times, okay, so we're going to rewind. I'm not even going to erase this in the video because I did the same thing that I yell at people for doing all the time, and it was dumb. Guys, I got rid of a square root by doing what? By square rooting! Come on, brain! How do you get rid of a square root? You get rid of a square root by squaring. 1/4 is my x. Oh, I would have been so mad if I did that on a real AP. Alright, so I mention it because, like, no matter how good you are at math, sometimes your brain does something so dumb, and it's frustrating. Like, I am by no means amazing at math, but I'm probably better than average, and I do stupid stuff like this. So you're gonna do stupid stuff like that sometimes. You can't beat yourself up too much. So anyway, so after all that work, right, I get that x is 1/4, but then I need the y coordinate because they said point, right? They said find the coordinates of point P. Well, I need f of 1/4, which would be the square root of 1/4, which is 1/2. So the answer is 1/4, comma 1/2, and man, I'm mad at myself for square rooting to get rid of a square root, right? You know, that's just ridiculous. Hogan, it's ridiculous. Anyway, it happens.